Okay, now let's go solving this question, everybody. Now we have the question read does. It said the density of water is what? 1 grams per cm cube, while the density of ice is 0.9 grams per cm cube. Calculate the volume, calculate the change in volume when 90 grams of ice is completely melted. Okay, now here we have comparing two materials here, that of ice and that of what? Water. Now, to solve this is very simple and direct. How do you go about it? Now, let me, knowing fully well that the ice at 90 grams, when it has fully melted, it will melt completely to water, having the same 90 grams. Knowing that while melting or freezing, there is no change in mass. Mass remains the same, but volume may differ. So it is the variation of the volume that brings about the variation in the density. Now check this. From density, as we know, to be equal to mass over volume. Okay, mass being kept constant, we discover that density is inversely to volume. Do we understand this now? Meaning that between the water and the ice having different densities is actually because of the fact that they have different what? Volume. So the volume, when volume reduces, what happens to density? It increases. When volume decreases, the density does what? They are inversely to each other. Okay? But mass being constant means that, okay, now for this 90 grams of ice, let me get the volume of that 90 grams of ice. When ice is 90 grams, what volume of ice weighs that 90 grams? Okay, that's what I'm talking about. Of course, we know that, recall, from density as equal to what? Mass over volume. Now, this 90 grams is for what substance? Ice, right? And ice has what density on the board? Okay, for density 0.9 equal to, what is the mass? The given mass of the ice is what? 90 grams. 90 grams over, let me estimate the volume. Okay, at that time. So we have 0.9 V equal to 90. Is that correct now? So let me divide both sides by 0.9. What do we have there? V equal to what? 100 cm cube. So you know what that means? It means that for the ice block to weigh 90 grams, and knowing fully well this is the density of ice, then ice at 90 grams automatically has a volume of what? Now let's see what happens to that ice when it has completely melted to water. Of course, we should expect a change in the volume. Shouldn't we? Yes, we should. Okay, now let's go back to water. Recall also, okay, that density is from, okay, equal to what? Mass over volume. Density of water here, we're giving density of water to be what? 1, the mass. Now listen, if this ice at 90 grams melts completely to water, of course, expect the mass of the water to still be what? 90 grams. Do you understand what I'm saying now? So the mass of the water still remains what? 90 grams, constant. But volume, expect a change in the volume. Expect a change in what? All right, so here we have what? V times 1, V. 90 times 1, 90. What does that mean to you? It means that, ice block at 90 grams, okay, has a volume of 100 cm cube. And when it melts completely to water of the same mass, then you expect the volume to have reduced to 90. Therefore, the change in volume becomes 100 cm cube minus what? 90 cm cube. So that gives us the temperature volume change to be what? 10 cm cube. Very simple.